Welcome everyone. In this video lecture, we will solve a problem based on the Mosfet, a small signal model and its operation. So the question is, a Mosfet is to operate at ID 0.1 milliampere and it have transconductance value 1 milliampere per volt. So the given thing in the question, I'm writing, given thing in the question is the drain current is given 0.1 milliampere and the transconductance parameter Ga is also given 1 milliampere per volt. So we have to, and in addition to that, the value of K and S, or we can say the mu and COX value is given 50 microampere per volt square. So we have to find the W by L, that is our aspect ratio, and overdrive voltage, that is our VOV, which is basically VGS minus VT. So these are the things which are given. So we have to find these two parameters. So in this question, we have to very first we have to know a relationship between ID and GM. Okay. So why this one I am writing? So the ID current in saturation. In most of the time, we are writing the drain current in saturation, not in linear, because the transistor is used as a amplifier, so it will work as a amplifier, better amplifier when it is in the saturation region. So the value will be 1 by 2 mu n cox w by l vgs minus vt whole square. This one is the equation for the drain current in the saturation region, and the transconductance we know gm mu n cox w by l vgs minus vt. Okay, so these two are the two equation. Okay, so one can write id expression like 1 by 2 gm vgs minus vt, because the term, this term, this transconductance term mu n cox w by l, and instead 2 we can write it gm. Okay, so 1 by 2 gm and 1 vgs minus vt, so we can write like this. Okay, so the id value is just id equals to 1 by 2 gm vgs minus vt, or in some paper you can see the value of the transconductance is twice id by vgs minus vt, or some formula will be like this, twice id by VOV, overdrive voltage. So okay, so id and gm is given, so we have to find VOV. So VOV can be written as twice id by gm. Okay, id value is known to us 0.1 milli, so I am writing 10 to the power minus 3, and gm value is also given 1 milliampere. Okay, minus 3, so this should be cancelled out, so it should be simply 0.2 volt. So the VOV value we can simplify 0.2 volt, that is our VGS minus VT. This one is also we can say VGS minus VT. So this one is the expression for the overdrive voltage, and this is coming from this formula. If you remember the formula, it's okay, or you can do by using equation 1 and 2 for drain current equation saturation and transconductance parameter. So my in earlier my past video I have already mentioned so many things related to this one, so better to go for the earlier video also. Okay, now this value we have calculated overdrive voltage first. Okay, overdrive voltage we have calculated. Okay. Now we have to go for the another one, that is our W by L ratio. Okay, so W by L ratio, now VOV is known to us, so ID is also we know the expression. So from ID we can ID is known to us, this Kn dash is known to us, and VGS minus VT is known to us. So we can easily find W by L. So first we have to write the expression. ID is again 1 by 2 mu and COX is nothing but simply writing Kn dash VOV whole square. Okay, VGS minus VT whole square means VOV whole square. So we have to find the W by L. So I'm just writing W by L is twice ID by Kn dash VOV whole square, or twice into ID 0.1 10 to the power minus 3 divided by Kn dash is our 50 micro. So better to write 10 to the minus 6 into VOV is 0.2. So better to write 0.2 into 0.2. Now we have to solve this one. So okay, so we can write it 0.2 into 10 to the minus 6, and here 10 to the minus 3. So we can write it 10 to the power 3. Okay, then after what we can write, okay, one more line we can write here. 0.2, this 0.2 cancel out, then this 10 to the power 3 and 50 into 0.2 means simply 10. Okay, so it should be simply 100. Okay, if we do cancel out, it will be 100. So the value of W by L will be simply 100. So this one is the answer. W by L, we have written the formula. Okay, means the drain current is 1 by 2. Now VOB is known to us by using these two expressions. Okay, because ID situation is there, so like that we can solve. So this one is a very simple problem, but we have to remember the drain current equation. Okay, and the transconductance parameter, everything. This GM we can find by, if you del ID by del VGS. Okay, it will simply give mu and COX W by L VGS minus VT, that is nothing but simply our GM. So this one is also formula. So you have to remember all this concept, or after practicing so many numerical you can easily get the expression for W by L and what I want. So this is all about this lecture. So thank you for watching this video, and this problem is from the Microelectronics circuits book. Okay, so thank you for watching this video.